Mastering microservices architecture design. Microservices failure is inevitable without a clear definition and measurement of reliability. Why is it essential for us to establish a clear understanding of how to define and measure the reliability of our microservices, so that we can ensure their consistent and high-quality performance in our operational excellence strategy? To ensure the consistent and high-quality performance of microservices in an operational excellence strategy, it is crucial to establish a clear understanding of how to define and measure their reliability. This involves implementing a robust monitoring and observability system, conducting regular security and vulnerability assessments, and adopting a proactive approach to issue detection and resolution. Defining reliability. Reliability can be defined as the ability of a microservice to consistently perform its intended function under normal and abnormal conditions, without interruption or failure. In the context of microservices architecture, reliability encompasses multiple dimensions, including availability, the percentage of time a microservice is usable and accessible to users. Performance, the ability of a microservice to respond quickly and efficiently to user requests. Resiliency, the ability of a microservice to withstand and recover from failures, errors, and unexpected changes. Security, the ability of a microservice to protect itself and its data from unauthorized access, breaches, and cyber threats. Measuring reliability. To measure the reliability of microservices, it is essential to establish a set of key performance indicators, KPIs, and service level objectives, SLOs, that provide insights into their performance and behavior. Some common KPIs and SLOs include uptime and downtime, measure the percentage of time a microservice is available and usable, and the frequency and duration of downtime. Response times and throughput, measure the average response time and throughput of a microservice, and the number of requests it can handle within a specified time period. Error rates and failure rates, measure the number of errors and failures per unit of time, and the percentage of successful requests. Mean time to detect, MTTD, and mean time to resolve, MTTR, measure the time it takes to detect and resolve issues, respectively. Implementing a monitoring and observability system. To measure and analyze the reliability of microservices, it is essential to implement a robust monitoring and observability system. This involves instrumenting code, adding instrumentation to the code of each microservice to collect telemetry data, such as logs, metrics, and traces. Collecting and storing data, using tools like Prometheus, Grafana, and DLK Stack to collect, store, and analyze telemetry data. Visualizing data, creating dashboards and reports to visualize telemetry data and provide insights into the performance and behavior of microservices. Alerting and notification, configuring alerts and notifications to detect issues and notify teams in real time. Conducting regular security and vulnerability assessments. To ensure the security and reliability of microservices, it is essential to conduct regular security and vulnerability assessments. This involves vulnerability scanning, using tools like a WASP-ZAP and Nessus to identify vulnerabilities in code, dependencies, and configurations. Penetration testing, conducting regular penetration testing to identify weaknesses and simulate real-world attacks. Compliance and governance, ensuring compliance with industry standards and regulations, such as HIPAA, PCI DSS, and GDPR. Secure coding practices, adopting secure coding practices, such as code reviews and static analysis, to identify and prevent security vulnerabilities. Adopting a proactive approach to issue detection and resolution. To ensure the reliability of microservices, it is essential to adopt a proactive approach to issue detection and resolution. This involves anomaly detection, using machine learning and statistical models to detect anomalies and unusual behavior in telemetry data. Root cause analysis, conducting thorough root cause analysis to identify the underlying causes of issues and errors. Collaboration and communication, fostering collaboration and communication between teams to share knowledge, expertise, and best practices. Continuous learning and improvement, encouraging a culture of continuous learning and improvement, where teams learn from failures and mistakes to improve the reliability of microservices. By implementing these strategies, organizations can establish a clear understanding of how to define and measure the reliability of their microservices, ensuring consistent and high-quality performance in their operational excellence strategy.